Today's Daily Dose of Math is about a problem where we have 3 students who are selling veggie dogs and bags of chips at a park. There's a lot of information in here, which is probably the most challenging thing about the problem. It's about interpretation and reading comprehension. Student A, sells 40 dogs and 50 chips and gets $130. B also gets $130, but by selling 30 dogs and 70 chips. C decides to double the price of both items. We still don't know the price of these items. And only sells 25 dogs and 12 chips. Well, that sounds like it's what I would expect to happen. It sounds like C is being a little bit greedy. Does C bring in more money than A or B? Is C rewarded for their greed? We don't have enough information to deal with C. We don't have enough information to make an equation for C. What we need is either the amount of money C makes, which is what we're going to find at the end of the problem anyway, or we at least need to know how much C is charging for the dogs and the chips. And the way to find that is to focus on A and B, where we do have more information, because for both A and B, we have numbers of dogs, numbers of chips, but we also have how much money they make. So this is a system of 2 equations, and the third equation will come later. First thing I want to do is define my variables. X equals the cost of 1 dog, and Y is the cost of 1 bag of chips. So I am being rather brief the way I talk about it. I'm just saying chips instead of bag of chips. I'm just saying A instead of student A, because I'm using half of my chalkboard just asking the question, and I need some room to answer it. If you were doing this on a real exam, there would be plenty of space to show everything. The question would be more complete and thorough, and your answer better be complete and thorough as well. The 2 equations I'm going to make are going to be, for A, 40 times the cost of a dog plus 50 times the cost of a bag of chips must give a total of 130. Very similar for B, 30x plus 70y equals 130. Now this is set up really well for elimination through addition, so that's the technique I'm going to use, but it could be solved with comparison or substitution if the student prefers. What I'm going to do is multiply the top equation by -3 and the bottom equation by +4. And that gives me 2 equivalent equations, which will be -120x minus 150y equals -390, and +120x plus 280y equals 520. Adding these 2 equations, the x's cancel. The -150 plus 280 gives me a +130y equals, and these combine also to +130. I'll isolate my y by dividing both sides by 130. These cancel and y is equal to 1. That means the cost of a bag of chips is $1. Now I'm going to plug that y equals 1 into one of the original equations. 40x plus 50 times 1 equals 130. 40x plus 50 equals 130. 40x equals 130 minus 50, which is 80. Divide both sides by 40. Cancel, and x equals 2. So the cost of a dog is $2. Now we have enough information to talk about student C and equation C. C decides to double the price of both items, so therefore 2 times the $2 price is $4. That's C's cost for a dog, and 2 times the $1 is equal to $2 is C's price for a bag of chips. To answer the final question, what I'm saying is 25, the number of dogs C sells, times 4, which is the cost C is charging for each dog, plus 12 times 2, the number of bags of chips, times the cost C is charging for a bag of chips. Is it greater than 130? Because that's what they're asking. Is C bringing in more money than A or B? I can do this with an equal sign, and I can still answer the question. 25 times 4 is 100, and 12 times 2 is 24. So I end up with 124 greater than 130, which is not true, so I'll put a line through it. 124 is not greater than 130. So the final answer is no, C only earns $124. C is not rewarded for their greed. And everyone who bought their dogs and chips from A and B got a better deal. That is the final answer for the question. But what is there to learn about this situation? How did we answer this question? We defined variables and we made a system of 2 linear equations and 2 variables. And then we did comparison or elimination or substitution to find the point of intersection between these two, which told us the cost of a bag of chips. Then we plugged into that cost into one of the equations to find the cost of a dog. We did the step where we doubled both prices because the situation said C was doing that. And then we do this last calculation to see if C earns more money than A or B, and we have our final answer. The only difficulty here is about that feeling of too much information. There's a lot of information in this paragraph. There's a lot of numbers, and you can't use all of the numbers right away. You have to pace yourself. I think that a student who is randomly given this question, no matter what math course the student is learning, would possibly struggle to understand, okay, what math situation is reflecting this? And to realize that you need the system of equations and the comparison or elimination to solve it. That is tricky, but of course most students who would get a question like this on some kind of a test have been studying systems of equations in the course they're going. So you want to be able to recognize that sort of situation because you practiced enough problems that work sort of like this. As far as C even existing in the problem, doubling the costs and figuring out whether C is bringing in more money, really all of that is there to add extra steps. To take a system of equations problem, which might be considered a bit easy, and make it a little harder by giving the student more things to do to fight their way all the way to the end of the problem. That is today's Daily Dose of Math. Please like, subscribe, and share.